Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the channel. Go ahead, hit the subscribe button if you're not already. Also, hit the like button. Like this video so we can get more into the algorithm. All right, drop a comment down below if you have any comments or if you have any questions about anything I explained. Please drop a comment and also share this video with somebody else, at least one other person. Now, what are we doing today? We are going to be multiplying two-digit numbers by one-digit numbers, or one-digit numbers by two-digit numbers. All right. And I'm specifically making this video for three of my nephews. All right. Three of my nephews, Zaire, Maceo, and Zen. All right. So Zaire, Maceo, and Zen, if y'all watching this video, make sure you're paying attention. Make sure you got a pen or a pencil. Make sure you got some paper. All right. And make sure there are no distractions. Make sure there are no distractions around you. All right. So look, before we get into this, we got three examples up here. I do want to also mention the ancestor Nat Turner, since I'm wearing one of my Nat Turner t-shirts. All right, Nat Turner, if we're not familiar, was a brother that was enslaved in the 19th century, which is from 1800 to 1899. That's the 19th century, 1800 to 1899. That's a little brief math lesson. All right. And he lived in Southampton County, Virginia, right? In Virginia, Southampton County, Virginia, which is just south of Virginia, south of Maryland. All right. And he decided that black people shouldn't be enslaved. And he decided to essentially go to war with those that did think we should be enslaved. So he started a slavery. He organized a slave rebellion in the year 1831 in August. In August, his slave rebellion is recognized every year during what we call Black August. August, every year, we recognize Black August. And the slave rebellion took place in August of 1831. So do some more research on Nat Turner and also not only his slave rebellion, but some other slave rebellions, because there were so many of them, right? That you most likely won't learn about in school. And we know why. But anyway, let's get back to the multiplication. So now, of course, you could just pick up your calculator, put in 7, multiplication sign, 23, equal sign, and get the answer. You can do that for all of these. But sometimes we don't need calculators. All right. Now, if you're a young person watching this, you're at an advantage. I didn't learn how to do this when I was real young. I discovered how to do this when I was an adult. So now if you're a young person watching this, you can have a head start on me. All right. So 7 times 23. All right. So that means 7 23 times. 7 times 23 is 7 23 times. So if you wanted to, you could just add 7, 7 plus 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 7 and do that 23 times, right? But that would take a long time unnecessarily, right? Time is valuable, right? Time is the only resource that we can't get back. All right. So we want to conserve our time and want to use our time wisely. So we use multiplication. But what we can do is we could say, let's imagine that we could decompose, which is a term you're going to learn in science, decomposition, or break down the bigger number. So the bigger number is 23. So you got 7 times 23. And let's say we broke down 23 into 20 and 3. Now, why would I break it down into 20 and 3? Because 20 ends in 0. And numbers that end in 0 are easier to multiply by than numbers that don't end in 0. It's easier to multiply by 20 than it is to multiply by 23. Because if I multiply by 20, check this out. I can act like that 0 is not even there. And I can act like I'm just doing 7 times 2 instead of doing 7 times 20. I can act like I'm doing 7 times 2. And this is also something else that you need in order to be able to do this successfully. You need to have your multiplication facts memorized. You need to have your multiplication facts memorized. So start practicing to memorize your multiplication facts. All the 1 facts, 2 facts, 3s, 4s, 5s, 6s, 7s, 8s, 9s, 10s, at least up to the 12s. At a minimum, at least up to the 12s. But you don't have to stop at the 12 facts. You can memorize the 13 facts, 14 facts, 15 facts, go up to the 25 facts, however far you want to go. But at a minimum, you should know from your 1 facts to your 12 facts. All right. I mean, you should know what 12 times 12 is, 12 times 3 is, 12 times 8 is, 12 times 9 is. You should know what 6 times 1, 6 times 2, 6 times 3, 6 times 4. That's what I mean when I say your facts. Your 6 facts are 6 times every number up to 12. Your 12 facts are 12 times every number up to 12. That's what I mean by that, in case you're wondering. All right, now back to this. 7 times 20 is the same thing as doing 7 times 2. And then you just take that product, which is 14, and then you just attach a 0 to it. So 7 times 20 is just 140, because 140 is what you get when you have 14 and you write a 0 next to it, right? Attach a 0 to the 14, and you get 140. So we do this. We say 140. And now the goal is for you to be able to do this mentally. Mentally. I'm writing it out to show you what's being done. But the goal is for you to do this mentally. I do this mentally. And you too can do this mentally. Right? You don't have to write this down. All right. When you're in the store, going to the cash register, you might want to find out what your total is before you wait for the cashier to tell you, or before you wait for self-scan checkout to tell you. You should already know using your own brain. All right. So 7 times 20 is 140. Then you do 7 times 3. That's 21. Again, another multiplication fact. 140. Then you're going to add these two together. Add these two together. Because really, multiplying 7 by 23 is, you could break it down anyway. You could do 7 times 10, then do another 7 times 10, then do a 7 times 3. You could do it that way if you want to, right? Also keep in mind that multiplication is just repeated addition, right? So you can basically just break this up. And this also, in school, you might hear of a method called partial products. Partial products. So this is another way to represent partial products. It's also a way to represent something we call, which is the distributive property. The distributive property. Because what we're doing is, this 23 becomes 20 plus 3, and we're distributing this 7 to the 20 and to the 3. Distribute means to give out, right? Like when you're in school, in class, your teacher distributes a book to every student. Your teacher might distribute a test to every student. Your teacher might distribute a permission slip for a field trip to every student, right? So like in this problem, we're distributing a 7 to the 20. So we can do 7 times 20 and get 140. We're distributing a 7 to the 3. So we can do 7 times 3 and get 21. And our last step is to add these two numbers together. So we still have to know how to do addition. 140 plus 21. 140 plus 21 is just 161. How do I know that? Because if I break down 21 into 20 and 1, 140 plus 20 is 160. And then the one that's left over, add that, you get 161. So 7 times 23 is 161. All right. Now, with practice, right, you'll be doing this real quick. Now, I know it seemed long when I explained it. Somebody watching this is inevitably going to say it. That took too long. That's doing too much. Of course, it's going to take a long time if I'm giving a detailed explanation. In real life, like when I'm doing this real quick. 7 times 20 is 140. 7 times 3, 21. 140 plus 21 is 161. Boom. That was less than 10 seconds. Of course, my explanation didn't take 10 seconds because I'm giving you all the details. All right. So don't anybody ever watch, whether it's this video or any other video, and think, oh, that's too long. Of course, it's going to be long. It's going to be long because I'm giving a detailed explanation. And the detailed explanation is going to take much longer than how long would it actually take in real life and in real time. Keep that in mind. All right, let's go to 48 times 9. 48 times 9. So I got 48 times 9. Now let's break down 48. Now, what? Watch this, though. Watch this. I could break 48 down into 40 plus 8. 40 plus 8. But notice what I'm doing. Notice the pattern. Math is all about patterns. I'm breaking the number down into the biggest number less than that number that ends in 0 and the difference. So 48 is the same as 40 plus 8. I'm not going to go to 30 because if I go down to 30, then I got to add 18. And 18 is another 2-digit number. I don't want a 2-digit number. That complicates the math. I want the math to be as simple as possible. So I'm manipulating the problem so that I can make the math simple as possible. So I'm not going to make 30 plus 18. Why would I do that? That's not going to help me. So I could break it down into 40 plus 8. But look, what else could I do though? Watch this. Couldn't I make this 48? Couldn't I rewrite it as 50 minus 2? Because isn't 50 minus 2 the same thing as 48? Think about it. 50 minus 2 is also 48. So we could also do that. I could have did 30 minus 7 instead of doing 20 plus 3. I could have did 30 minus 7. We got options. That's the thing about math. In math, you have a lot of options. There's never going to be just one way to do a problem correctly. So let's do it. Let's do it this other way. Let's break this down into 50 minus 2. Let's do that. All right. Now, 50 minus 2. Now we're going to distribute the 9 to the 50, distribute the 9 to the negative 2, because there's a minus sign in front of the 2. There's a negative 2. Don't be uncomfortable if you never worked with negative numbers before. I'm gonna explain with that how you work with those two. All right. So 50 times 9. 50 times 9. We could pretend, right? Like sometimes in life, we got to pretend sometimes, right? We pretend the 0 is not there. We do 5 times 9 or 9 times 5. Commutative property. The order of the numbers doesn't affect the final product that we end up with. So 9 times 5, if you know your multiplication facts, you know 9 times 5 is 45, right? And then you attach the 0. So 45 becomes 450. Then you do 9 times negative 2. Now, whenever you multiply a positive number by a negative number, the product is what it would be if they were both positive, except you give it a negative sign. 9 times -2 is -18. You need to know your multiplication facts. You know that 9 times 2 is 18. But because you're multiplying a positive by a negative, it's not going to be positive 18. It's going to be -18. It's going to be on the negative side of the number line at -18. All right. So instead of doing plus 18, we're going to do minus 18. So 450 minus 18, we could do 450 minus 10 and get 440. And then we could do 440 minus 8 to get 432. 432. Now, real quick, watch this. Watch this. What if I did it the other way? I broke this down into 40 plus 8. We can still do that. 40 plus 8. 40 plus 8. Watch this. 4 times 9. Treat the 40 like it's a 4. Treat the 40 like it's a 4. 4 times 9 is 36. Attach the 0. You get 360. Then you do 8 times 9. What's 8 times 9? You need to know your multiplication facts. If you don't know them by heart, that's fine. Go get a multiplication table. All right, pause the video. Go get a multiplication table. Go get one of those black and white marble composition books, right? And look in the back flap. Look on the back flap. Or just go online, pull up a multiplication table. Pull up Google multiplication table. Boom, right? If you don't have that right, if you don't have the numbers memorized yet, all right, eventually you will have them memorized just from doing the practice, just from multiplying. From the act of multiplying, you're going to have them memorized eventually. Then we got 8 times 9. That's going to be 72. So now we got 360 plus 72. And you see why I wanted to do it this way? Because the subtraction is easier because we're subtracting a smaller number. Here we're doing 360 plus 70. All right, 360 plus 70. I know that I could break 70 down into 40 and 30. Now, why is that helpful? Because I know 360 plus 40 is an even 400. So once I add the 40, I get 400. Then I add the other 30, I get 430. Then I add the 2, I get 432. And isn't that what I got when I did it the first way? So I still get 432. So it don't matter. You still going to get 432. All right? But just familiarize yourself. Like, there's different ways to do these problems. Now, let's do the last one. 76 times 5. 76 times 5. So the bigger number, we break that down or decompose it, right, into 2 numbers. One number that ends in 0 and the remainder, right, or the difference. So I'm going to break this down into 70 and 6. If you want to, you could do 80 and 80 minus 4. We could do 70 plus 6, or we could do 80 minus 4. Whatever way you want to do it, you're still going to get the right answer as long as you do your multiplication and your addition or subtraction correctly. All right. So 70 times 5. I treat the 70 like a 7. I pretend it's a 70. I'm sorry. I meant to say I pretend it's a 7. I pretend it's a 7. And I know that 7 times 5 is 35. So then I do 35 with the 0 at the end. Boom, 350. And then I do the same thing with the 6. I'm distributing. So in school, you're going to learn about something called the distributive property. The distributive property says that you can multiply a number by a quantity, which is being added or subtracted, right? And you multiply the number by both of those numbers. So we distribute the 5 to the 70 and we get 350. We distribute the 5 to the 6 and we get 30. 350 plus 30 is 380. That's what we get. Now, real quick, this video is running long. Let's do this one more time. So let's do this over. Let's do 76 times 5 and let's break it down into 80 minus 4. 80 minus 4. Let's distribute the 5. 5 times 8, because I could treat the 80 like it's just an 8. I could treat the 80 like it's just an 8. So 5 times 8 is 40. Then I'm going to attach the 0 and we get 400, right? And then 5 times -4. Remember what I told you on this problem? What happens when you multiply a positive by a negative? Your product is always negative. Write that down somewhere. Whenever you multiply a positive number by a negative number, your product is always going to be negative. Your product is always going to be negative. All right. So instead of it being positive 20, 5 times -4 is -20, which means you're going to subtract 20. All right. So 400 minus 20. Now, 400 minus 20, if you had $400, right? And then you subtract $20 from $400, you get $380. Look at that. We got the same answer. Did it 2 different ways and got the same answer. See that? All right. Now, so just an introduction on how to multiply 2-digit numbers by 1-digit numbers. But you know what I forgot to do? Let me do this real quick. Real world applications. Imagine, right, a team football team, NFL team, right, had, 23 touchdown and point after combinations. 23 of them. Touchdown for 6 points. Kick the extra point afterwards for an extra point, right? That's 7 points total. They did that 23 times. We want to know how many points is that? It would have been 161 points. 161 points. 48 times 9, let's say you get $48 in allowance, right? 9 times. That happened 9 times. You get $48 in allowance. You want to know how much money that will be altogether. 48 times 9, that would be $432. All right. 76 times 5. Let's imagine 5 cents is the value of a nickel. The value of a nickel, right? When you look at a nickel, it's got Thomas Jefferson on it. Make sure you're aware he was a slaveholder and a racist. All right. Even though he was a president of the United States, that says a lot about this country, right? But anyway, that's another conversation for another time. All right. Just like George Washington. All right. So, but anyway, 76 times 5. Let's say you got 76 nickels. How much money is that? Right? And change. 76 times 5 is 380 cents. If one nickel is 5 cents, 76 nickels is 380 cents. And 380 cents is the same thing as $3.80. 380 cents is the same thing as $3.80. All right. 380 cents, same thing as $3.80. All right. So these are just some real world applications that you can use to apply to these numbers, right? Because these numbers are kind of random, but they could represent real world situations. All right. So like I said, this was for my nephews, Zaire, Maceo, and Zen, and anybody else too. But I made this video with them in mind. So hopefully they watched and they learned something from it and it added value. And now they know how to multiply 2-digit numbers by 1-digit numbers. All right. Also, anybody else, make sure you're subscribed to the channel. Make sure you drop a comment. Make sure you like the video and make sure you share this video with at least one other person. All right. See y'all later.